Okay, back to the front page. Now that we've looked at a piecewise function and have talked a little bit about the one-sided limits, the left and right-hand limits, we now know how to resolve this notation, and we know what it means. Again, this would be the left-hand limit, and this would be the right-hand limit. So let's go ahead and take a look at example 1 in more detail. So here is a plot of sine of x over x, and we're just going to point out really quickly here that there's a hole in the graph at x equals 0. So if I were to sketch it, there'd be a hole. So this value, whatever this y value is here, should be 1. There's no value there. So in particular, we can emphasize this by saying f of 0 is undefined. Okay. So what we want to do here is use numerics to determine the one-sided limits of f as x goes to 0. Are they equal? If so, what does this mean? So clearly, geometrically, we can answer this question very quickly. We're going to practice with numerics, though. So let's go ahead and just say what this is going to be. We know from visually, from looking at it, that as x approaches from the left of sine of x over x, we get 1. And as we approach 0 from the right-hand side, we also get 1. Okay? So, whenever we see, we haven't talked about this yet, whenever the one-sided limits, the left and the right-hand limit, when they agree, then there really isn't any point in distinguishing between the two of them. If they agree, then what's the point? There's no need to talk separately about the left and the right if they are the same. So in that case, so if the one-sided limits agree, we just write the limit as x goes to 0, and we don't put a plus or minus sign after the value to distinguish or to denote a left or right hand limit. We just say from as x goes to 2, or excuse me, as x goes to 0. There's no need to specify. So we just write the limit as x goes to 0 of sine of x over x equals 1. So this actually means that the limit exists. If there is a discrepancy between the one-sided limits, like we saw in the previous video of a piecewise function, we can quickly jump back to that. Here, we can see that the left-hand limit here is 4, the right-hand limit is 5, so clearly these two one-sided limits over here, they do not agree, so we would actually say, so they disagree. So the limit as x goes to 2 of f does not exist. And we always just write DNE instead of writing out does not exist. So DNE is a very important abbreviation. Okay. So using some numerics here, how can we arrive at this same conclusion without, what if we just gave this function without a graph? So if we didn't have a graph, how could we do this? All right. So one way we can do this is, let's go ahead and do the left-hand approach. So for the left-hand limit, what we're going to do is consider the value of the function f of x equals sine of x over x. And we're going to look at that value for different values of x, where x is going to start to the left of 0 and work its way towards 0 from the left. So for instance, maybe we have negative a tenth, negative 1/100th, and negative 1/1000th. If we plug those in to sine of x over x, we see that for negative 0.1, we get 0.9983. For negative 1/100th, we get 0.9999. And if I am only rounding to 4 decimal places, I used Excel and I had it set to 4 decimal places. So when I plug this in, negative 1/1000th, Excel actually spit out 1. And that's because it rounded to the 4th decimal place. So what this actually means, so I'm going to cross that out and just say it is it's a consequence of rounding that we got 1. Really, this means we have something like 0.99999, something like that. It's all 9s beyond the 4th decimal place. So maybe it stops after the 5th or the 6th. We don't know. I didn't take it out that far. But we definitely know that the first 4, at least the first 5, are definitely 9s. Or the first 4 are 9s, and the 5th decimal place is a 5 or larger because it rounded up the 4th to make it 10000. All right. So we can see that the trend here, there's an obvious trend as if we were to continue downward, like looking at maybe a 10,000th or whatever, we can see there's an obvious trend where we're going to head towards a value of 1 for the limit. And we can go ahead and do the right-hand side as well. There's a certain symmetry here, which is nice. So for instance, sine is an odd function. Remember, what does it mean to be an odd function? The definition of an odd function is that f of negative x equals negative f of x. So this means sine of negative x is equal to negative sine of x. And it just so happens that the denominator, x, is also odd. So negative x is equal to negative x. That sounds really dumb when you say it, but it's true. Therefore, it's an odd function. So what do we get here? If we have sine of x over x, and we plug in a negative value for it, so for instance, if we look at sine of negative x over negative x, sine being an odd function means we have we have negative sine of x over negative x, which is just the same thing as sine of x over x. So what's nice here is, let's erase the part that I don't really need. What we find is this, sine of negative x over negative x, is exactly the same as sine of x over x. So if you compare this chart, we are plugging in negative x's, and if I do the right-hand limit, I'd be plugging in positive 0.1, positive 0.01, positive 0.001. So I'm just going to use this argument right here to say that we're going to have the same exact results by symmetry, an odd symmetry. And in fact, an odd function divided by an odd function is an even function, and this right here is an even function because you can fold it about the vertical axis. There's a line. The vertical axis is a line of symmetry. So we're going to skip doing the table for the right-hand limit because it's literally the same. So what does this tell us? Well, this tells us the left and right-hand limits are the same. So we have the limit as x goes to 0 from the left of sine of x over x. That equals 1, which is also the same as the limit as x goes to 0 from the right of sine of x over x. So this implies that the limit as x goes to 0 of sine of x over x exists and is equal to 1.